Hi everybody. In the previous video we talked about the free radical polymerization, and I told you that it does not give us any control over the polymerization, and we can say somehow that we will finally result into a huge mess. So the polymer chains that we finally get, they differ a lot in the matter of their size. So you see that because there is no control over the growth of the polymer chains, we will have a broad distribution of the molecular weight, and as a result of that, the broad distribution of their sizes, the length of the polymeric chains, and as a result of that, the polymeric nanoparticles that we will finally get will definitely differ in their size. However, we mentioned about the other polymerization techniques, which are called as the controlled and living polymerization, which gives us the ability to control the polymerization reaction in order to, instead of leading into a huge mess, I told you about the popcorns, how they, pop up suddenly. We want to grow our polymers just like a group of grass, all of them together. Well, this controlled and living polymerization gives us a great ability to play a little bit with the monomers that we're going to polymerize to form and shape the macromolecules with different shapes. Well, for example, you see here the star-like polymer, and the reason that such interesting macromolecule has been formed is due to using a multi-branch initiator, multi-arm initiator at the beginning, so that the polymerization can start at different branches. And because it is controlled, when we reach a certain size of our polymers, we will change the monomers into the, you can say, you see the blue and the red ones, and continue the reaction with that. Well, on the other hand, we can also form the brush-like macromolecules. And how are they formed? Well, just you see that this brush is composed of different parts of the brushes. Okay, so if you consider only this one as a monomer which has a double bond here, if the double bonds open their arms, one in this way and one in that way, or when the polymer is formed, you see that these regions will connect to each other and they will form a brush-like. Let's have a better look in this picture, and you see here that this is our monomer, and it has a double bond for polymerization in this site. So when these double bonds are opened and they connect to each other, this is the backbone of the macromolecule that we will finally get, and these are the brushes that we have. And we can also functionalize these ends of our brushes, with the targeting sites, targeting molecules, with the drugs, and etc. But anyway, just remember that thanks to the living polymerization, and based on the initiator and the sequence of the monomers that we are going to use, we can lead into the formation of, star-like, even the brushes, and even the copolymers. Let me show you the copolymer. Well, you see here that we have a block copolymer constituted of the polymer type A, B, and C. Okay, and you see that first this part has been formed, and after that, by introducing the monomers B and C, the block copolymer has continued to the formation of the macromolecule. And as another example, we can also use the enamers, as you see here. Well, an enamer is a combination of a monomer and an initiator. Okay, so the ini for the initiator and the mer for the monomers. And when we use such molecules for the polymerization reaction, they will lead into the branches, because each initiator can stick to the other monomers, and again different branches will be formed, and we do not necessarily lead to a great and perfect straight line. Again, in this slide you can see that by the use of the enamers, the branched like, or the so-called dendritic hyperbranched macromolecules can be formed. And we also mentioned the copolymers composed of different types of polymers here, and also the brush-like macromolecules. So these are the features of the controlled and living polymerization that gives us the ability to control the formation and the growth of the polymeric chains. But now what I want to do is to characterize the controlled and living polymerization based on the kinetics, the rate of reaction, and see how the propagation of monomers into the polymers is going to occur.